All right, welcome back. And now what we're going to do is we're going to start talking about inequalities, graphing inequalities, and then systems of inequalities. And so this is going to be a little different than what we're dealing with equations, systems of linear equations or non-linear equations. So here we go. So what we have here is an example of a linear inequality. Okay, so in here we've got ax plus by is less than c. Now, granted, so this is called a linear inequality, and it's obviously the only difference is between this and a linear equation is the fact that we have an inequality symbol here. Now, we could replace this with any inequality symbol. It could be less than or equal to, greater than or equal to. So the symbol can be replaced here, but this is what we would call a linear inequality. Now, any point that makes this inequality true is a solution, just like when we dealt with equations, right? Now, if we take all of the points that make this inequality true, then we call that a solution set. Okay? So here are some words, right, that we want to make sure we know. Solution and solution set. Okay? Now, graphing an inequality is pretty straightforward. It's not hard at all. Okay? It's really just two steps. And I'm going to explain this. I didn't write out everything in detail. So I'm going to just explain it and just you take good notes. So here, step one is what you're going to do is you're going to change this inequality into an equation. That's what the related equation means. So you're just going to replace this with an equal sign, and then you're going to graph the resulting equation. Now, if the inequality symbol is strict, meaning that there's no equal sign, so either less than or greater than, okay, we call that a strict inequality. If it is one of those two inequalities, then we would graph the equation with a dotted line. Okay, meaning that the line is not going to be included in our solution set. Okay, if it is not a strict inequality, meaning that we do have an equal sign, in other words, we're dealing with either less than or equal to or greater than or equal to, then we would represent and graph that line, the equation, as a solid line. Okay, meaning that the line is going to be included. All the points on the line will be included in the solution set. Once we graph the line, right, the equation of the line, then what we do is we use a test point. So we're going to choose a test point on either side of the line. It doesn't matter which line. You typically want to use a point that's easy, right? Typically, the origin is a great point, right? The origin will usually land on one side or the other side of the line. Now, the only exception is if the line actually goes through the origin, then we're going to have to use a different point. But the point is you want to use a point that is easy to easy to plug in, right? Okay. So now what are we going to do with that test point? Well, like I said, we're going to plug it into the inequality, and we're going to see if that point gives us a true statement or a false statement. If the point gives us a true statement, then we're going to shade everything on that side of the line where we took the test point from. And that's the half plane. So that side of the line would be the half plane. Remember, we're talking about a plane, right? A line through the plane partitions the plane into two halves, right? We call those half planes. So if the point we plug in gives us a true statement, right, a true inequality, then we're going to shade in the half plane on the side of the line where we took the test point from. Now, if we get a false statement, then that just means that we're going to shade in the half plane that's on the opposite side from where we took the test point from. Okay, and that's it. That's all there is to graphing inequalities. So now we'll do some examples.